In this lesson, we'll install MonoGame and set up a new project. First, head over to monogame.net, the official website. Click on Getting Started. Now choose your system, whether it's Windows or Mac. For me, I'll select Windows. There are several methods to install MonoGame. I'll go with the recommended approach, which is via Visual Studio. If you don't have Visual Studio, you can click here, then go to Download and select the Community Edition. After downloading it, you will see something like this. Make sure you have .NET Desktop enabled, then click Install. Next, we will need to install the MonoGame extension for Visual Studio. To do that, launch Visual Studio, then select Continue without code, go to Extension, then Manage Extensions. Now type MonoGame in the search box and install the one you see here. When it finishes, click on the Close button and close the editor. Then, just wait until the installation of the new extension finishes. Now, to create a new MonoGame project, launch Visual Studio, then select Create a new project, then search for MonoGame and select the cross-platform desktop application, then hit Next. Write your project name and then hit Create. Now you have created your MonoGame project. Let's import the sprite files. To do so, under Content, run this file. You should see the Content Manager window. You can create a folder here. Let's create one for our sprites, and then let's import all the project sprites, which, by the way, you can find them in the project zip file. Now, after importing any asset, you have to click on Build, then Save and Close. That's it for this lesson. I will see you in the next one. In this lesson, we will learn a little more about MonoGame and how we can create our own game manager. So, this is what the MonoGame project looks like when you open it. Let's start by replacing game1.cs with our own game manager script. To do that, I will create a folder by right-clicking, then selecting Add, and then Folder. Let's call it Script. Now I will add the script by right-click, select Add, then choosing New Item, write the name of the script, Game Manager in this case. Then hit Add. Now the first thing we need to change here is the word internal. Write public instead. Now go to game1.cs. Here you can see some properties at the top and game1 initializer and also the initialize method. If you scroll down, you can also see the load content method and lastly the update and draw methods. Keep in mind that update and draw run every frame, meaning if your game works at 60 frames per second, update and draw will run 60 times per second. Anyway, what we need to do now is to copy everything from this class and paste it into our game manager script. Rename game1 method to game manager method, as it should be the same as your class name. One more important thing is you can see game1 is derived from game. Our game manager should also have that. For me, everything gets imported automatically. If it's not the case for you, make sure you have the same imports as my file. Now after you finished copying the script content, remove game1.cs file. If you run the game now, it won't work yet and will give you this error. This is because we also need to change our project starting point to be the game manager. To do so, go to the program script and change game1 to script.gameManager. Of course, don't forget to save your script when you change anything. Now if you run it, it should work. With that, we concluded this lesson. I will see you in the next one. In this lesson, we will focus on our player script. First, right-click on the script folder, then select Add, then New Item. Let's name it player.cs. As usual, change internal to public. Now that we have our player script, let's instantiate it. Navigate to Game Manager and create a reference to the player script so we can spawn it. To do so, write private player_player. Now, let's spawn the player. Scroll down to the load content method and add _player =new player. Now, let's play the game. It should run, but you won't see any changes yet. That's because we haven't drawn the sprite for the player. Let's do that now. Go to player.cs. Define a property of type texture2D. Let's call it sprite. Now create a new method called loadContent. Let's write sprite game manager dot instance dot content dot load, then texture 2D inside angle bracket, and the path for the player sprite as the string parameter. Now that we've loaded the player sprite, it's time to draw it. Define a new method named draw with sprite batch parameter and call the method spriteBatch.draw. Set sprite property as the first parameter and vector.0 for the position parameter, and lastly color white for the third parameter. That should be sufficient. However, we're not calling these methods yet. To do so, let's create an initializer method for the player and call loadContent within it. This will only call the loadContent method. For the draw method, we need to go back to Game Manager. Under the draw method, call _spriteBatch.begin. And then call player.draw passing sprite batch. Then call spriteBatch.end. Now let's hit play again. You should see the player appearing on the screen. That's it for this video. We will continue working on the player script in the next one. In this lesson, we will learn how to read input from the keyboard and control our spaceship with the WASD keys. Open the player.cs class. Define a new method called update, which takes game time as a parameter. Inside it, we will define a 2D vector, and we listen to keyboard input. When the player presses WASD keys on the keyboard, we change the X and Y values for the vector to match the movement direction. So to do that, let's define a property of type vector2 called direction and set it to 0. Get the state of the keyboard by calling keyboard.getState and store it in a variable. Check if the W key is pressed by calling keyboardState.isKeyDown. If it's pressed, set direction.y to -1, which will make the spaceship move forward. Now repeat this process for the S, A, and D keys. The value of X and Y should be either 1 or -1 depending on the movement direction. Now to see if the direction value changes when I press WASD, let's print the direction value by writing debug.writeLine, passing the direction vector as a parameter. Before running the game, make sure to call the player update method from the game manager update, or else it won't work. If you run the game now, you should see the value of the input direction change as you press W, A, S, or D. That's cool, but the player isn't moving yet. To make our player move, we will need to define speed and position for the player, so that when he presses on WASD keys, we change the player's position by the defined speed. Okay, so go to the player script. Below the texture at the top, let's define a float for speed and give it any value. Also, define a vector2 to store the position. Then, in the update method, add direction multiplied by speed to the position value. To make sure speed won't get affected by the user FPS, multiply by the float value of gametime.elapsedGametime.total seconds, which is the time between every 2 frames. If you're wondering why we added this, remember that players' devices vary in GPU and CPU speeds. Therefore, a player who can run the game at 120 FPS will have their spaceship moving much faster than one with a PC running at 60 FPS. To prevent that from happening, we move the spaceship with smaller steps on the 120 FPS devices and bigger steps on the 60 FPS device, which results in both moving at the same speed. That's exactly what will happen when we multiply by elapsed game time. Let's run the game. As you can see, we can't move the spaceship yet. This is because we are not using the position to draw our sprite. This is also an easy fix. Go to the draw method in the player script and change vector2.0 to position instead. Now hit play. As you can see, we can control the player's spaceship, which is really great. Okay, we reached the end of this lesson. I will see you in the next one. In this lesson, we will create our first obstacle. We will create parent obstacle class and also meteor class as one implementation of that parent class. Let's start by creating a class for obstacle.cs. which will serve as the parent class for all of our obstacles. Change internal to public. Additionally, let's create another class for our meteor obstacle called obstacle_meteor.cs. Change internal to public as usual. In the parent obstacle class, let's define shared properties that we believe all obstacles should have. In my case, these are vector2, position, float speed, texture 2D sprite. To tell C# that this class should only be used as parent class, we should make it as an abstract class by just writing abstract before the class keyword. And also write some abstract methods. I will define update, which takes gametime parameter, and draw, which takes sprite batch and gametime parameters. I think that covers it for now. Next, go to the meteor obstacle class and set the parent class for it. Write the required method to match the parent class. Let's have an initializer method that accepts a position. Inside it, set position property to position parameter. And load the texture in the same way as we did for the player. Make sure the properties in the parent class either public or protected to fix this error. For the update method, we just need the meteor to fall down. So let's change the position.y by speed multiplied by the total elapsed time. Let's set the speed value to something greater than 0. For the draw method, we will draw the obstacle normally by calling the sprite batch.draw method, giving it the texture, position, and white color. Basically, there's nothing new here. Now, to test our meteor, let's spawn it from the game manager by having a reference to it. And spawn it within the load content method. Also, let's not forget to call the obstacle update and draw from the game manager. Finally, hit play. You should see the meteor on the screen. That's it for this lesson. See you in the next one. In this video, we will create a spawner class which will be responsible for spawning enemies and obstacles. So, the way we will do it is, we will learn how to make a timer to execute code once every few seconds. And every few seconds, we will pick a random point on the screen and spawn an obstacle there. Let's start by creating a new class. Call it spawner.cs. Change internal to public as usual. Then, let's have an update method which takes game time as a parameter and a draw method which takes game time and sprite batch as parameters. you should already be familiar with those methods. And if you remember, to make those methods work, we need to tell our game manager about the spawner script and call those methods from there. To do so, go to Game Manager and define a new property of type spawner named _spawner. In the Game Manager load content method, initialize the spawner and store it in the _spawner property. Then, in the Game Manager update method, call _spawner.update and pass the game time for sure. And in the Game Manager draw method, call spawner.draw and pass game time and sprite batch. Very good. Now back to the spawner class. In order to run code every few seconds, we will need to create two time spans here, one for spawn rate and another for timer, and we will keep adding the elapsed game time to the timer in the update method until the timer is equal or greater than the spawn rate, which is when we will run our code to spawn the obstacle and reset the timer. This will continue forever. So, let's define the obstacle spawn rate of type timespan. Let's give it a value of timespan.fromSeconds 3, which basically means 3 seconds. Now, let's define the obstacle spawn timer, which is also of type timespan. However, the value here should be timespan.0. We have the timer property now. Let's write the logic for it. Scroll down to the update method and here, add the gametime.elapsed gametime to the obstacle timer. This will add a few milliseconds every frame to the timer, based on the player device frame rate. Then, check if the obstacle spawn timer is greater than or equal to obstacle spawn rate. If that's the case, reset the timer to 0. This should be it for the timer. Let's test it by writing debug writeLine and put any string, for example spawn. So, if we run the game, we should see the spawn message every 3 seconds. Which is definitely the case, as you can see. Now it's time to spawn meteors instead of printing a message. So, let's break it down. To spawn the obstacle here above the screen viewport, we can have the Y value as -100 or something like that. However, we need the X to be random between the left side of the screen and the right side of the screen. Then, we will spawn a new obstacle meteor and pass this random position to it. Let's start doing that. Inside the spawn update method, define a variable of type random equal to new random. Now define an integer called randomX. Set it equal to random.next. It will ask you to pass the minimum and maximum value. For the minimum value, use 0. And the max value is the screen width. You can get the screen width by writing GameManager.InstanceGraphicsDevice.Viewport.width. Now, let's define the position variable equal to new vector 2. Use the randomX for the X value. And let's put -100 for the Y value. Finally, let's create a new meteor by writing new obstacle meteor and pass the position. This is exactly how we spawned a test meteor inside the game manager in the previous lessons. And by the way, since we don't need that test meteor from the previous lesson, delete the reference from the top and delete it from the load content method too. Also, remove the update and draw calls. So we are good to go. Hit play. Well, there are no errors, but there are no meteor showing on the screen. This is because we didn't call obstacle meteor draw and update method yet, which will be the topic of the next lesson. We've reached the end of this lesson. I will see you in the next one. In this lesson, we will continue working on our spawner class. Our objective is to update and draw the meteor on the screen, as well as manage the deletion of meteors that cross a certain boundary below the screen. Let's begin with the updating and drawing processes. To achieve this, we will create a list to hold all the obstacles. During the spawner's update process, we will iterate through this list, invoking the update method on each obstacle. Similarly, within the spawner's draw method, we will loop through this list again, but call the draw method for each obstacle instead. Firstly, within the spawner, let's declare the obstacle list and initialize it with new list. Next, immediately before we instantiate our meteor in the spawner update, let's store the meteor into a variable of type obstacle, name it current obstacle. After this line, we'll add the current obstacle to our list. This step is crucial for ensuring that every new obstacle is included in the list. Now, to enable the drawing and updating of obstacles, in the update method, loop through all the obstacles, calling the update method for each. Repeat a similar process for the draw method, where you loop through all obstacles, calling the draw method for each one of them. By implementing these steps, we should be able to see the obstacle appear on the screen. Let's press play and observe the result. Indeed, we now have meteor appearing on the screen, which is quite exciting. However, consider what happens to the meteors once they move beyond our viewport. Currently, our code continues to loop through these meteors, invoking the update and draw methods unnecessarily. This inefficiency can lead to performance issues over time. To solve this issue, we will instruct our spawner that any obstacle passing a certain boundary below the screen should be removed from the obstacle list. This ensures that the update and draw methods are no longer called for these obstacles. To implement this, let's revisit our spawner update method. Inside the loop, immediately after updating a meteor, check if the obstacle's position on the y-axis is equal to or greater than the screen height plus 100 units. If this condition is met, remove the obstacle from the list. Remember to adjust the loop index accordingly by decrementing it by 1 to account for the change in the list's indexing. To further organize our code and create room for future additions, let's encapsulate the spawning and management of meteors into a single method. Define a new method named handleMeteors. Cut the code from the update and paste inside the new method. And don't forget to add game time as a parameter to this method too. Finally, within the update method, don't forget to call handle meteors. This keeps the update method clean and more manageable for future expansions. This is really great. I like how the game is shaping up. So, this concludes our lesson. I will see you in the next one.